Artlist.io.
What's up guys, and welcome back to the Calculusaurus channel. Now in this tutorial, let's go ahead and consider a small cart moving along the streets of Snake Way with a given acceleration of a of t is equal to beta times t, where beta assumes a value of 1.2 meters per second cubed. Now for the first part, we want to go ahead and find the velocity of the bus at t is equal to 2 seconds, given that at t is equal to 1 second, its velocity is 5 meters per second. And for the second part, we'll go ahead and want to calculate the position of the bus at t is equal to 2 seconds, given that at t is equal to 1 second, its position is 6 meters away. Now, for a bit of background info before we go ahead and get started, we have to go ahead and recall the relationship between position, velocity, and acceleration. So recall that if you have a position as a function of time, and you take the derivative of that, you go ahead and get velocity as a function of time. Now, with velocity as a function of time, if you go ahead and take the derivative of that, then you go ahead and get acceleration as a function of time. Now, all of this is going in one direction, but let's say that you were given acceleration, which is what we have in our case, and you want to go ahead and find velocity and position. And so the way to achieve that is through integration. And so by integrating acceleration, you'll go ahead and end up with a function of velocity. And if you go ahead and integrate velocity, you'll go ahead and end up with a function for position. All right, so now that we've drawn this relationship diagram, we know that in order to get the velocity at time is equal to 2 seconds, we're going to have to integrate our acceleration function to get our velocity function. And once we have our velocity function, we're going to use some initial condition to go ahead and find out what c is. And having c, we'll go ahead and be able to evaluate the velocity of this bus at time is equal to 2 seconds. And so we know that our acceleration function, once we go ahead and plug in the value for beta, is equal to 1.2t. And additionally, we know that at time is equal to 1 second, our velocity is 5 meters per second. And we want to go ahead and solve for v of t, or the velocity, at time is equal to 2 seconds. So the first step, let's go ahead and integrate our acceleration function a of t dt. And so plugging in the values that we know that this is going to be equal to the integral of a of t, which is 1.2t dt. Now recall from calculus that we can go ahead and pull out any constant from the integration operation. And so we can go ahead and pull out 1.2, and we'll just go ahead and end up with the integral of t dt. And finally, using the power rule, we know that the integral of t is equal to 1.2, which is still hanging out on the outside, times t squared divided by 2 plus c. And if we go ahead and distribute the 1.2, we'll go ahead and get 1.2 t squared over 2 plus c. And thus our velocity as a function of time is equal to 1.2 t squared divided by 2 plus c. Now, before we can actually evaluate what the velocity of this bus is at t is equal to 2 seconds, we have to take care of this unknown constant c. And so to go ahead and figure out what c is, let's go ahead and use the fact that at t is equal to 1 second, our velocity is 5 meters per second. And so plugging these conditions into the equation that we formulated, we'll go ahead and end up with v of t, which in our case is 1, is equal to 1.2 times t squared, which is 1 squared, divided by 2, plus c. Simplifying this, we know that at t is equal to 1, the velocity is 5, is equal to 1.2 divided by 2 plus c. Now to go ahead and solve for c, let's just go ahead and move 1.2 over 2 to the other side, and we'll get 5 minus 1.2 divided by 2 is equal to c, which simplifies down to 4.4. And so now that we have our value for c, our velocity function becomes 1.2t squared divided by 2 plus 4.4. And so now that we have our velocity function, we can go ahead and evaluate this function at time is equal to 2 seconds to find this bus's velocity. And so plugging in 2 for t, we'll go ahead and get 1.2 times 2 squared divided by 2 plus 4.4. And so we'll have that our velocity at time is equal to 2 is equal to 6.8 meters per second. Alright, so for the last part, we want to go ahead and find the position at time is equal to 2 seconds, given that the velocity function is equal to 1.2t squared divided by 2 plus 4.4, and additionally, we know that at time is equal to 1 second, the position of this bus is at 6 meters away from its starting point. And so, recalling the relationship between velocity and position, we know that as we take the integral of velocity, we'll go ahead and come up with position as a function of time. And so we'll have position as a function of time is equal to the integral of velocity dt. And going ahead and plugging in the velocity function, we'll have the integral of 1.2t squared divided by 2 plus 4.4. Now, let's go ahead and simplify that 1.2 divided by 2, and we know that that shows 0.6. And so we'll have the integral of 0.6t squared plus 4.4. And as the final step, integrating this function, we'll have 0.6 t to the power of 3 divided by 3 plus 4.4 t plus c, our arbitrary constant. Thus, our position as a function of time is equal to 0.2 t to the power of 3 plus 4.4 t plus c. And so before we evaluate our position at time is equal to 2 seconds, we're going to have to find what our arbitrary constant is using the initial condition that at t is equal to 1 second, our position is 6 meters. And so we'll have x of 1 is equal to 0.2 times 1 to the power of 3 plus 4.4 times 1 plus c. Now, we know that at time is equal to 1 second, our position is 6, and so our equation becomes 6 is equal to 0.2 plus 4.4 plus c. Now, in order to go ahead and obtain c, let's just go ahead and cross all the other constants to one side. And so we'll have 6 minus 0.2 minus 4.4, and we get that c has a value of 1.4. Thus, our position as a function of time is equal to 0.2 times t to the third power plus 4.4t plus 1.4. And so now that we have our position function, let's just go ahead and evaluate it at time is equal to 2 seconds by plugging in 2 for t. And so we'll end up with the equation x of 2 is equal to 0.2 times 2 to the third power plus 4.4 times 2 plus 1.4. And evaluating this expression using the calculator, we'll get that the position at time is equal to 2 seconds is 11.8 meters. Thus, at time is equal to 2 seconds, the position of this bus on Snake Way is 11.8 meters from its starting point.
Artlist.io